Okay, welcome to this video on trig graphs, and it's a wee introduction into trig graphs, the basic trig graphs that you need to know at National 5 level. Now, the ones we're going to explore is sine, cos and the tan graphs. And sine, cos and tan, they're actually circular functions. Okay, it's all to do with a circle and rotating round the circle. So the circle that we're going to deal with, and this is the standard, so this is the standard graphs, involves the unity circle. Now the unity circle has a radius of 1, so the hypotenuse for this triangle is 1. And going back to probably third year, you did SOHCAHTOA, so you found ratios for sine, cos and tan. So that point xy that we've got there, that is from the origin, so this is the origin at the centre. That point is defined as being x along and y up, so the point is xy. And using your knowledge from trig in third year, using triangles, then you should know that sine theta, sine of the angle, this is the angle here, sine theta is the opposite over hypotenuse. So that's actually y over 1 because the hypotenuse is 1 in this case. Therefore, sine theta is simply the value of the y coordinate as we rotate round the circle. And we can do exactly the same for the cosine function. So cos theta is the adjacent over the hypotenuse, so that's x over 1, and therefore cos theta is simply the value of the x coordinate as we rotate round the circle. And the tan function, again from third year, is the opposite over the adjacent. So tan of the angle is equal to the y coordinate over the x coordinate. And we can't do anything with that, then it's just that ratio. So what I'm going to do is we're going to plot the values of the angle as we rotate round this unity circle. So it takes 360 degrees for us to draw the sine graph. Now it's the value of the y coordinate as we go round. So I'm going to split my graph on the right hand side here into 4 sections, and just space them out a wee bit. So we'll go there, there and there. And you can see that the x-axis, the horizontal axis, is actually the angle. So it's the angle we're talking about here. So if we start at 0 and we go round the full circle, then we end up at 360 degrees in a circle. And halfway would be 180. And halfway again from 180 to 0 would be 90. And this would be 270. Okay. Now, hopefully you can see as we rotate round the y value, well, if we start at 0 degrees, well, the y value will be 0 because it will just be a straight line here. But as we rotate round, it will get to 90 degrees, and the value of that will be 1. It will just be the hypotenuse. And again, it will go low, low, and eventually we'll get to 0 again because the vertical height will be 0 at 180. Then 270 will be another value, and then up to 360 again, and then it just goes round in circles all the time. So the graph just repeats itself after every 360 degrees. So this is how it looks. Well, at 0, then the y coordinate is 0, so we'll just put a wee point in there. At 90 degrees, so imagine this getting bigger and bigger up to 90 degrees, then at 90 degrees the value of the sine function will be 1, so I'm just going to put 1 up here, and that's the maximum value. Can't get any higher than that because it's a unity circle we've got. And at 90 degrees you don't really have the triangle because it's just a vertical height. When we get to 180 as we go down, so the y coordinate as we go down to 180 will be back to 0. That'll be here. And as we rotate down here and get to here, then that's just a vertical line again, but it's going in the opposite direction. So that is deemed to be -1, whereas up here will be 1. So I'm going to put a value down here somewhere of -1. Make that a wee bit bigger to around about here. And then the y coordinate as we go round to 360 is back to 0 again. So if we plot that, then this is the shape of graph we get. That. There's a symmetry about it, okay? It's sort of meant to be sort of curvy. It's not a semicircle. Lots of people think it should be a semicircle, and at first glance I think most people think that, but it's not a semicircle, it's a sort of curvy type one, and this is the maximum value here, and this is the minimum value. So what you expected to know? Well, you'd expected to be able to draw that sine graph. So that graph is y equals sine theta. That's that graph. Lots of times we replace the theta by x, so we just call it x. You'll see in lots of textbooks they just call it y equals sine x. But the theta, it's an angle. I just put x there just so that's what we normally see in textbooks. But the x is not really the x-axis. Well, it is the x-axis in a sense, but it's really the angle. We're measuring an angle, so it's important that you remember that. So what you expected to know? Well, the shape, the maximum value. You're expected to know the maximum value of a sine function is 1, and it occurs at theta equal to 90 degrees, or x equal to 90 degrees. You're also expected to know that the minimum value, the min value is -1 at theta equal to 270 degrees. You need to know that, you have to memorise that. Okay, so that's a minimum value. Also, the period of the wave, now the period is how long does it take to do one cycle. So the period of the wave is equal to 360 degrees. It takes 360 degrees to complete a full wave. And that should be obvious because it's defined over a circle, and the circle is 360 degrees. Okay, it crosses the horizontal axis at 3 places, so crosses horizontal axis, horizontal at 0 degrees, 180 degrees and 360. Okay, that's all the things that you're expected to know at National 5 level. Right, let's look at the cos graph. Well, the cos graph this time, remember it's adjacent over hypotenuse, but the hypotenuse is 1, so the cos theta is simply the x coordinate, Okay, so it's the value of this x coordinate as we rotate round a full circle. So I'm going to do it here. So what we're actually plotting here is going to be y equals cos theta. And again, most textbooks will have the x in there, not to be confused with this x. We'll keep it as theta just now, just to show you. So the angle as we rotate round the circle, and we're plotting the value of the x coordinate as we go. So just like we did above, we're going to put in 4 sections. So that's 360 degrees, 0, 90, 180, 270, just as the same for the cos, sorry, for the sine. So just before we start to plot it, well, this is the unity circle again, so it can only go up to a maximum of 1, so we'll put 1 here, and down to a value of -1. because it's a unity circle, so this x value can only go up to 1 or down to -1. So as we rotate round, well, when we start on x equal to 0, the angle is 0, it's on the horizontal, and that's when the x value is a value of 1. That's when it's, so it's got a value of 1 when the x is, when the angle is 0. So this angle is 0, x is up to this circle here, it's just a horizontal straight line. When we get to 90, so if we rotate round and get to 90 degrees, well, you can see the x coordinate will be here, and it's a vertical line, so the value of the x coordinate is 0, so it's 0 on here. 180, so as we rotate round to 180, well, the x coordinate doesn't go that way anymore, it's away over here at -1. So this is -1 here, and that's 1 because it's a unity circle. So at 180 degrees it's -1, so it's down here. At 270, as we rotate round here to 270, well, the x coordinate, remember it's the x coordinate, it's the horizontal. That's 0 again because that's a vertical line down the way. So it's going to be 0 again. And when we get back to 360, well, that's the same as 0 degrees really, isn't it? Because you just went one complete revolution. We're back at 1, so it's up here somewhere. So what shape does that look like? Well, let's hope I can draw it. Not too bad. It goes like that, around here like that, and back up here. So it looks something like that. So that's your y equals cos theta. Yeah. So again, not to be confused with this x, but in textbooks you tend to see theta named as x degrees. Okay, so what do you have to know for that? Well, it's the same as the sine graph. So we have to know the I'll put it over here, max value. Max value is 1. Minimum value is equal to -1. And the max value occurs at 0 degrees. So max occurs at theta equal to 0 degrees. And for the minimum value that occurs, well, minimum value is -1, so it's here. So it's going to happen at 180 degrees. Because remember, we should put theta in there when theta is equal to 180 degrees. The period of the wave, again, the period of the wave is 360 degrees round a full circle, and cuts horizontal axis at theta equal to 90 degrees and 270. Right, 0 and 270. So that's that point here and that point here. So maximum 1, -1. It occurs at 0 degrees for the maximum. Also occurs at 360 up there, yeah, but we usually take 0 here. And the minimum at 180 degrees, and it cuts at 90 and 270. Again, you have to commit that to memory. This axis is called amplitude. Essentially the height, the value, the length of the x coordinate. For the sine function, it was the length of the y coordinate. This is called the amplitude. So you need to get used to that word, amplitude. Right, the last one we have to do is the tan theta one. Now the tan theta one's quite strange. It's the ratio of y to x. Now it's not easily, I can't easily show you or simplify anything. So I'm just going to show you it. So 90 degrees again, 180, 270 and 360, so we're going round the circle. Well, it turns out, I'm going to put wee dotted lines in here and I'll explain what they are in a wee minute. At 90 degrees, so here's my wee dotted lines. Okay, and I'm going to put another wee dotted line at 270. It'll become clear why I'm doing that. These dotted lines are called asymptotes, and I'll explain a wee bit more about that in a minute. Well, let's look at the ratio at various times. When theta is equal to 0, so it's just a horizontal line there. Well, what we've got then, we've got tan of 0 degrees is equal to the y coordinate. Well, the y coordinate when it's horizontal here is 0, so that's 0 over, and the x coordinate is 1. 0 over 0, so sorry, 0 over 1 is 0. So tan is 0 degrees, this is 0 degrees here, is the value 0. So I'll put this one in red. So the value of the tan function at 0 degrees is 0. Now at 90 degrees, so let's look at 90 degrees. When we've got tan of 90 degrees, well, what's that look like? Well, the y value at 90 degrees, this is straight up here. Well, the y value will be 1, so that's going to be 1 over, and the x coordinate is 0. That's undefined. We can't work that out. If you put that in your calculator, then you'll get an error, say maths error or something. It's undefined, we can't calculate it. So what actually happens, this graph, this is how the graph looks. The ratio gets bigger and bigger and bigger, and it keeps going, but it never gets to 90 degrees. It gets close and close to it, but never actually gets there. So we can't find a value for tan at 90 degrees, it's undefined. So this line, this vertical line, is called an asymptote. It's a line that this curve tends to, but never gets there. It can't get there. So what happens there? Well, we don't really know. It goes to infinity. It just doesn't get there. But what happens after 90 degrees? Well, after 90 degrees, you're just over here a wee bit. So if you think about it, just over here, well, we can work that out. That's just like having it over here a wee bit. So as we rotate round, so I'm going to look at it at 0 degrees again. So at 0 degrees, sorry, not 0 degrees, 180 degrees. When we get to 180 degrees, what does that look like? Well, tan of 180 degrees. Well, if we're here now, right, if we're rotated round to here, then the y coordinate is 0 again, because the line's here, height 0, and the x value is 1. So again, that's 0. So for 180 degrees, the tan function is 0. Let's look at 270. At 270, it's a vertical line again. So let's just work that out. Tan of 270. Well, it's a vertical line but down the way this time. So the y coordinate is 1 and the x coordinate is 0 again. So again, it's undefined. We can't work it out. So that's why I put a dotted line at 270, again called an asymptote. Now, what actually happens after 90 degrees, the tan function comes from negative infinity, goes up and curves round to 0, and then it curves again and back up and up and up and tends to 270, but it doesn't get there. Just like at 90 degrees, it never gets there because the ratio is undefined as it gets closer and closer to 270. And after 270, well, it comes from here again, from negative infinity, and goes up to 360, as you would expect, because we're back round to 0 degrees really. So that's what the tan graph looks like. But you maybe notice here, there's going to be a slight difference. We can't work out the maximum value because it goes away to infinity, so there isn't a maximum value for tan. So I'll just define that. This is the y equals tan theta. But again, I'll just put in brackets x, because in most textbooks and most worksheets it will say tan x, but it's actually the angle, remember? It's not the x coordinate, it's the angle, but they tend to, rather than using theta, they tend to use x degrees. So, we can't find a maximum value, we can't find a minimum value. We can find out when it crosses the x-axis, and we can find the period as well. Now, the period is defined as the time taken to repeat itself, or how long it takes for one wave. Well, hopefully you've noticed this. If I start here at 0, the period of a wave will be the next time that the tan function is 0. So it shoots off to infinity as it approaches 90 degrees. Then after 90 degrees it comes back from negative infinity and curves up to 180 degrees, and that's 0. And that we started at 0 degrees and a value of 0, the amplitude was 0. So the next time it's 0 amplitude again is 180. So the period is 180 degrees, not 360. So you've got to be careful with that, because that curve there and that curve there, it's just a repeat of that one. So you get two tan graphs, if you like, in 360. Now we can define where it cuts the horizontal axis. Cuts horizontal axis at, well, cuts at 0, cuts at 180, and if we want to do it over 360, we could say it cuts at 360 again, but that's, remember, that's two waves. So if we're only talking about one tan function and where it cuts the axis, we really should just have 0 and 180, because 360 is the next wave. So as you, for the sine function, as you go around the circle, this wave just continues forever. For the cos function, as you go around, you get this shape, and then again it just goes on forever as you're going around the circle. So you can go around as many the circle as many times you like, it's rotating round. These waves just repeat themselves. And for the tan function, it repeats itself every 180, but that's the shape of it. Okay, so that's all the basics you need to know. So you need to commit this to memory. Okay, and what we're going to do in the next video is we're going to draw some sine graphs, cosine graphs. We might actually even do some tan graphs, but we're going to give you some graphs and you're going to write down the equation, and you'll find out that they have some things in common. Okay, so that's a quick introduction to trig graphs. If you want the animated version of this, it's on mastervision.com under National 5 under trig graphs, and if you look at the first PowerPoint, there's a wee link to a demo that actually works quite well to show this. Okay, that's us finished for this one.